So today's lesson is about the binomial distribution. The lessons we've had leading up to this have talked about a probability distribution, and you guys know a probability distribution is basically like a table or a thing that tells us the probability of different outcomes happening, right? In order for us to talk about a binomial distribution, I first have to talk to you about a thing called a binomial trial. The idea is that a binomial trial is just some event that has two possible outcomes. And so the first thing that comes to mind is the idea of flipping a coin. Flipping a coin is absolutely a binomial trial because realistically there are two things that happens. It's either heads or tails, right? But that's not the only binomial trial, right? You could even see something like rolling a fair die as being a binomial trial. Now somebody might say, well, wait a minute, that's not for there's 6 possible outcomes. That's true, but if I were to think of that event as either getting a 5 or not getting a 5, or getting an even number versus not getting an even number, or getting a prime number versus not getting a prime number, like there are ways that we can take almost anything and turn it into a binomial trial. For example, looking out the window and seeing what the weather is. Like, it's either raining or it's not raining. Like, with most things, there is a way to look at it as being a binomial trial, as something either happening or something not happening. Okay, so that's what a binomial trial is, and that's pivotal to our understanding of what a binomial distribution is. So the next statement is that the binomial distribution is used anytime one of those binomial trials I just talked about, anytime one of those is carried out multiple times, and we want to know the probability of some certain number of successes. So for instance, this is my first example here, right? A coin is flipped 8 times. So right there, that's the whole, 8 times it was carried out multiple times. What's the probability of obtaining exactly 5 tails? That 5 tails is the number of successes that I wanted. Okay. For this next example here, if a student has a 75% chance of successfully throwing a piece of trash in a trash can, so there's your binomial trial. When you throw the piece of trash, it either lands in the trash can or it doesn't. Right? So first of all, you've got, the event is carried out multiple times. They attempt 10 shots. What is the probability they will make at least 7 of them? That's your desired number of successes. Now, what's interesting about that one is it says that they'll make at least 7 of them in the trash can. So what that means is that you're going to need to look at the probability of them getting 7 of them in the trash can, plus the probability of getting 8 of them in the trash can, plus the probability of 9 in the trash can, plus the probability of 10 in the trash can. And I hope that makes sense. Like, the idea is the binomial distribution, this thing, will tell us what the probability of any individual occurrence is, so if they want at least 7, we'll just have to write down all the possibilities. It looks horribly annoying, and it would be hideous to do this by hand. When we use the calculator, which is what the second video is about, you'll find that there are a lot of, quick tips and tricks that you can use to get through this stuff quickly. So we'll take a look at that when we get there. This video, though, is really just about how we set the problems up and how we do these problems if it's a non-calculator question. So if you look in your IB formula book, I think it's on page 5, down near the bottom it says, I think it's 6.10, the binomial distribution. It gives you this hideously long formula for how to do the binomial distribution. And I don't want to dwell on this for too long, but let me sort of walk you through what this formula says. First it says, if your random variable is distributed binomially, in other words, if you're doing a binomial distribution, which means this part isn't really part of the formula. It's just saying, hey, if you have a binomial distribution, then the probability of you having R successes is this. And by the way, the number of successes could be 0, 1, 2, 3, all the way up to n. So this stuff at the end isn't really part of the formula either. Really, the formula is this center section here. But even that's a little bit hard to read. The reality is, this part is the formula part, and I think we can sort of write it in a simpler fashion. This thing down here is the formula that I would recommend you use for the binomial distribution. Okay? So it means you have to remember it, or at least you have to remember that this NR thing just means NCR, right? But if you've got that thing, then, I can sort of show you the simplified version of the formula. So I'm going to scroll down so we can talk about that more. So the simplified version of the formula, if you have a binomial trial, we talked about binomial trials, that has been carried out n times, so n is the number of trials that you have, with the probability of success, p, in other words, p is what your probability of being successful is, then the probability of obtaining exactly R successes, so that's the number of successes you want, is given by this formula. Okay? So all you have to do is find the number of trials, plug it in for n, find the probability of success, p, put it in for P, find the number of successes you want R, put it in for R, run it through this formula, and you'll get the probability. Okay. I don't know that I'm actually going to work out the next example, but I at least want to talk about how you would set this problem up. So for this one, a coin is flipped 4 times. Right away, what variable is that? That's me saying that n is 4. My number of trials is 4. Right? So this is trials. Right. Next, what is the probability of obtaining exactly 1 tail? So tails is the thing, my success. So my probability is going to be 1/2, because the probability of obtaining, of getting tails in 1 trial is 1/2. Last, what is R? What is my number of successes? Well, we want to have exactly 1 tail, so that's 1. Sometimes this is referred to as the x value, because you're saying, hey, that's my variable. That's the thing that I want to have happen. So now, according to the formula, this would be 4c1 times 1/2 to the first power times, now 1 minus p. If you look at 1 minus p, 1 minus p is going to be 1 minus 1/2, which is another half. And then the power is the n minus r power. N minus r is 4 minus 1, which is 3. And this would sort of be the answer to the question. And we can go further than that. We can simplify that. 4c1. If you look at Pascal's triangle, 4c1 is 1, 4, 6, 4, 1. So that's 4c1. So 4 times 1/2 times 1/8. So it looks like 1 out of 4 is actually the probability of this exact thing happening. I don't want to leave you guys too in the dark on this, because this formula should make more sense than just us plugging stuff in. Take a look at this. What this really says is, this says, hey, the probability of getting tails is 1/2. You wanted to get 1 tail. Okay, if you get exactly 1 tail out of 4 shots, what exactly does that mean? That means you also must have gotten 3 heads. And so what you're looking at is 1 tail times 3 heads times the number of different ways that could happen. Right? I mean, we could have had heads, 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 tails. We could have had heads, heads, tails, heads, heads, tails, heads, heads, or tails, heads, heads, heads. There were 4 different ways this could have happened, and so I'm multiplying the whole thing by 4. So that's sort of why and how the formula works. I've got 1 or 2 more examples lined up for us, so let's take a look at those. So keep in mind, all the problems I'm doing right now, I'm doing from a non-calculator perspective, because on the exam you might get them on a non-calculator section. If you're in a calculator section, these get way easier, and that's what the next video is about. But for now, we're looking at how we do these things for a non-calculator. Right? So this next example, consider a biased die for which you have an 80% chance of rolling a 6. The die is cast 5 times. Right? So Part A, write an expression for the probability of obtaining no 6s. So we sort of need to figure out what is n, in other words, what's the number of trials. We need to know what's p, what's the probability of success, and what's r, what's the number of successes that we want. In other words, what's that x value. Alright, so I'd recommend you pause the video, think through this, write down those numbers, and if you're up for it, even write down, use the formula to figure out what the next part would be. Okay, so my number of trials. Well, it says the die is cast 5 times, so that's my number of trials. What's my probability of success? Now you have to really look carefully, because it's not necessarily 80%. Let's look at this. Write an expression for the probability of obtaining no 6s. So what is it that I want? What I want to get is sort of 6s. So what's the probability of getting a 6? Well, we're told that's 80%. So my probability is 0.8. Now R, what is the number of those successes that I wanted? It says here that I wanted no 6s, right? So we would put 0 here. Okay, great. So now that I have that, I can write the formula. The formula says it's going to be 5c0 times p, that's 0.8, raised to the 0 power. Then I'm supposed to do 1 minus p, so that's 0.2. And think about what that represents. 0.2 represents not getting a 6, right? And if you got a 6 0 times, that means you didn't get a 6 5 times. Okay? So now if we actually wanted to compute this thing, what is 5c0? We can get 5c0 by looking at the 5th row of Pascal's triangle. 1, 5, 10. And I kind of don't even have to write down the rest of them, because the first number right here is 5c0. So I have 1 times 0.2 to the 5th power. So my answer is 0.2 to the 5th. On a non-calculator section, I feel like leaving these things in a form like that is totally acceptable. Okay. Now question B. Question B is a really important question, so make sure you've got your brain turned on for this. Hence, write an expression for the probability of obtaining at least 1/6. Right, so for question B, they want the probability of at least 1/6. Now, what exactly does that mean? That means the probability of 1/6 plus the probability of 2 6s plus the probability of 3 6s plus the probability of 4 6s plus the probability of 5 6s. One option is to do that formula up above 5 times. Instead you'll be changing the R values. You'll have to use, R is 1, and then R is 2, and R is 3, and R is 4, and R is 5, and compute all 5 of those things and add them all up. Or, there is an easier way. The probability of getting at least 1/6, the probability of getting, 1 6, 2 6s, 3, 4, 5 6s, that should be the same as 1, that's 100%, minus the probability of getting no 6s at all. Because think about it, the probability of getting at least 1/6 should be 1 minus the probability of not getting any 6s at all. And you really should pause the video for a minute and make sure that makes sense to you. So if I know that, well, wait a minute, probability of 0 successes, that's totally what I got up here. I can just put that in. I'll have 1 minus 0.2 to the 5th, and that's my expression. That's my answer. Okay. I think I've got one more example for us to look at, so we'll jump over and look at that briefly before we move on. Okay, so an archer has a 90% chance of hitting a target. If she looses 9 arrows at the target, what is the probability she will hit the target at least 2 times? Okay, I'm not actually going to solve this problem. I'm just doing this in preparation for the next video, which talks about calculator usage. Okay, so what do they want here? They want the probability of hitting at least twice. So what does that mean? That means the probability of 2 hits plus the probability of 3 hits plus the probability of 4 hits. Okay, that's really annoying. I really don't want to do this problem for 2 hits, 3 hits, 4 hits, 5 hits, all the way up to 9 hits and add all of them together. That's a horrific amount of work. Instead, how could I write this as a 1 minus? Right? Like in some sense, what's the opposite of hitting the target at least twice? Wouldn't this be 1 minus the probability of hitting 0 or 1 times? And again, make sure that makes sense, right? Hitting the target at least twice would mean 2 or 3 or 4 or 5 or 6, all the way up to 9. The opposite of that would be hitting the target only once or twice. So if I just do 1 minus the probability of hitting 0 time or 1 times, I can just do 1 minus the probability of 0 hits minus the probability of 1 hit. Even if I had to do this by hand, it's much easier for me to do this than for me to go through this whole process. And when we get to the next video where we're talking about using the calculator, you'll see that it's an even faster process. So the assignment you're going to see after these videos will have some problems that are designed to be done without a calculator and some that are designed to be done with a calculator. Make sure you're doing them appropriately because they're completely different types of problems. So I'll see you guys in the next video.